So here we'll check out part D of number 4 from the 2012 AB exam. And in this piece of the problem, they want us to find the value of this integral. So we don't really need the problem statement at all because the function's kind of been changed a little bit. So we can just kind of dive right in and think about how we can take this integral. So using the first part of the fundamental theorem of calculus, we would want to find an antiderivative for this function and then take its limits of integration, 5 and 0, put them into that antiderivative, and then take a difference to get our answer. Now, taking this antiderivative is going to be a little bit tough. There's no algebra that we can do to simplify this. What we do have right here is we have a function that's underneath a root. So what we can try to do is we can try to do a u substitution. We can try to let u equal that inner function. And if we let u equal the inner function, the integral is going to be able to be rewritten as, rather than a root, I'm going to write it as u to the 1/2. Now I do still have this x from out in front of the root, and then in place of the dx we're going to have to figure out what to put. So in place of the dx we're going to take the derivative of u with respect to x to generate a dx to figure out what it equals. The derivative of this is 0, and the derivative of this piece is going to be minus 2x. So if I multiply both sides of this equation by dx and divide both sides by negative 2, by negative 2x, excuse me, this is going to be the quantity that I'm able to put in place of the dx. So if I put du over negative 2x in place of the dx, the thing that tells us that u substitution is going to be successful is that there's an x here in the numerator and an x here in the denominator that cancel with each other. We're now going to have an integral that just depends on u's. One thing that I haven't done anything with yet are these limits of integration. I'm going to leave them as x values. So I'm just going to give myself a little note here that those numbers, 0 and 5, are x's. I could try to turn them into u values by figuring out what u equals when x is 0, figuring out what u equals when x is 5 by plugging those values into this formula for u that depends on x. I'm going to leave them as u values. So after I take my antiderivative, I'm definitely going to have to put this back in place of u before I put numbers in place of any variables, because I need to put numbers in place of x's, not in place of u's. I'm going to get this negative 2 out in front of the integral. It is in the denominator, so when you take it out, you have to make sure it stays in the denominator. And we have a pretty simple antiderivative that we're going to have to take care of here, actually. We're going to add 1 to that exponent, and that's going to give us 3/2, and then we're going to divide by the new exponent. I don't know what I'm doing here. My notation isn't great. I was cleaning up the integral, and I still have an integral symbol here, and then I went and applied an antiderivative formula. So my current line should look like this. My next line is the one that I'm going to take the antiderivative in. So now, taking the antiderivative, I'm going to add 1 to this exponent. And so, like we had down a minute ago, that's going to give you a 3/2. And then dividing by the new exponent is the same as multiplying by 2/3. And we would have to evaluate this from x equals 0 up to x equals 5 and take a difference. Now these are x values here. I didn't elect to change them to u values. I'm going to have to substitute 25 minus x squared back in place of u before I put anything in place of any variables. So I'm just going to rewrite this as negative 1/2 times, I still am going to have 2/3 inside this quantity. It's kind of an ugly fraction bar that's going to bother me for the rest of the screen, so let me try to clean that one up. I know most of them are bad, but that one was exceptionally bad. And then in place of the u, I'm going to have this quantity go back in place of it. So 25 minus x squared ends up back in place of u. I can't forget about this exponent here. And now I'm going to be able to put 5 in place of x, put 0 in place of x, and take a difference. So I'm just going to leave my negative 1/2 here. And if I put 5 in place of x, what I end up with is 2 over 3. And then if I put a 5 in place of this x and square it, I get 25. 25 minus 25 inside this set of parentheses here is going to give me 0. So I have 0 to the 3/2 power, which is just 0. So 2 times 0 is 0. So this first piece is basically gone. And then minus what I get when I put 0 in. Well, when I put 0 in place of x, I end up with 2 over 3 still. And then 0 goes in place of this x. I have 25 minus 0 squared. That's just 25. So I have 2 times 25 to the 3/2 power. This piece went away. I do still need to distribute my -1/2 into this term. So that's going to make it a positive, right? Because I'm looking at a negative times a negative here. Now my 2 here and my 2 here are going to be able to cancel with each other. I could have gotten rid of those a line or two earlier. I just didn't see that at the time. And then this is something that can simplify. You know, anytime you have an irrational value, it's fine to leave it as an irrational value on a non-calculator problem. In this case, this is not an irrational value. This is something that will considerably simplify because this denominator in the exponent indicates the index on the root, so it's really a square root. And we can definitely do the square root of 25. Now I can't forget about the numerator from that exponent. I'm going to do the square root of 25, and then I'm going to cube that answer. And when I do the square root of 25, I get 5. And then when I do 5 times 5 times 5, 5 cubed, I end up with 125. So the result to this definite integral ends up being 125/3.